Assalamualaikum warahmatullahi taala wabarakatuh. To IR Rudianto Filmanjong. We are from Group 24. We are going to present the project 2 for the KNJ2332 Engineering Programming. Our group members are 4 people, namely Rahmat Husaini bin Rahman, Muhammad Lukman Hafizi bin Alwi, Muhammad Mukadim bin Muhammad Said, and Noizul Islam bin Azhari. Hi and Assalamualaikum. My name is Muhammad Mukadim bin Muhammad Said. I'm going to present the engineering problem for the project 2 of the engineering programming KNJ2332. First of all, our problem is stuntman want to break world record of a long distance jump. So our task is to calculate the speed or the minimum velocity for the stuntman to cross the obstacle. The distance of the obstacle is 1,000 meters, where he must pass a stack of car, and then the degree of the ramp that has been built for this particular event is fixed at inclined position 30 degrees. The challenge for the stuntman is to get known the minimum velocity for him to pass through it safely. The speed must be perfect, because if he goes too fast, it may miss the landing point, where the landing point is being put at the position of 1.7 kilometer from the starting point. The safety measure is not going too fast, because it causes the stuntman off from the trajectory and will resulting a stall, or landed maybe landed way before the landing point. Okay, that's all from my part. I'm going to pass my presentation to my group members. Thank you.
Hello, my name is Muhammad Lukman Hafizi bin Alwi, metric number 72447. So I'm going to present about the program design of our project. First one is algorithm. Algorithm is a step-by-step procedure which defines a set of instructions to be executed in a certain order to get the desired output. The second one is flowchart. Flowchart is a diagram of the sequence of movements or actions of people or things involved in a complex system or activity. And the third one is pseudocode. Pseudocode is a notation resembling a simplified programming language that used in program design. As you can see at the left part of the slide, we've made the flowchart. And this program starts with the initial velocity of 0, and it calculates the range. After that, it increased 1 km per hour into the initial velocity. Then, if the theta is equal to 30, the program will proceed, while else, if the theta not equal to 30, then it will come back to the start. When it proceeds, select data of initial velocity, and we can calculate the max range and max initial. After that, we display the value of the range and initial velocity that has been calculated. Lastly, we plot the trajectories of the stuntman for initial velocity with the arrays v initial equal to 5, 10, 140.
For the MATLAB code, the programming was done in script file instead of writing in the command window one by one. First, we write the script of initialize and array to hold range because we set the boundaries, or else it will calculate till infinity. Then it followed by script to write out the table of range that will give us the value of initial velocity with the range value. Next is script to calculate the range and initial velocities that will give us the value that can travel till 1.7 km to pass a stack of cars. Lastly, we add the script to plot a trajectories, script to add title and axis label on graph, and script to plot maximum range trajectories. These three scripts basically all about plotting a graph. This is how the script file works. First step, we need to write the script and rename it as Group24 Project2.m file. Then, at the command window, we enter back the name of the script file to run all the commands written in the file. The end result will appear along with the graph trajectories of stuntman versus initial velocities.
Assalamualaikum and good evening. I am Nur Izul Islam bin Azahari, metric number 72473. I will be presenting the sample output of the problem in our program. Here, I attach a table of comparison, value of program output and manual output, also the part of result of the program. As you can see, there are only a slight difference between the values of program output and manual output. This is because we tend to round off to the closest integer when we compute manually because we only use it up to 2 decimal places. Next, when the program is executed, a 140 line table of velocity and ranges is generated. For the computed velocity in the figure above, the software matches our human calculation, and the target range was obtained at a minimum speed of 139 km per hour. Figure 2 shows the graph of the trajectories for every initial velocity from 5 km per hour until 140 km per hour in the step of 10 km per hour. The data is represented in the graph as shown in Figure 2. The number of columns in an array determines the graph shape. As the number of columns in an array increases, the graph becomes smoother.